Hello students, welcome to the class. So in the previous class, we have discussed about ionic bond, ionic compounds, and what are the factors which affect ionic bond formation. In that, we have seen the factors such as ionization energy. One of the atoms should have very low ionization energy and another combining atom should have high electron gain enthalpy. Yes, then where the atoms combine very easily to form the ionic bond which is formed will be more stable. Yeah. Then third one, what we have seen is lattice energy. You can see here sodium neutral atom. Yes, it is losing one electron. It is losing one electron to form sodium ion, cation, Na plus. Yes, and the size of the cation has decreased. On the other hand, this electron is being taken up by whom? It is being taken up by chlorine. So chlorine neutral atom, it has gained one electron and it has become Cl minus energy. You can see here ionization energy 494 kilojoules. That means when you apply 494 kilojoules of energy to this atom, electron is being lost, and here it is minus 349 kilojoules. That means when Cl chlorine is taking an electron, it is gaining an electron, 349 kilojoules of energy is released. Okay, now when the two ions, when there is electrostatic force of attraction between the two ions, both of them combine and they form ionic crystal, and the lattice energy of the crystal is 787 minus 787 kilojoules per mole. That means when both the ions are combining, there is release of energy. We say 787 kilojoules of energy is released. It is released. So 787 kilojoules of energy is released. That is the understanding. Or in the other way, if you want to define lattice energy, I can define it as, how I can define it? I'll define it as the amount of energy required to break this crystal lattice. This is the crystal lattice, right? This is crystal lattice. So the amount of energy required to break the crystal lattice into constituent ions, that is nothing but lattice energy. So this is what we have discussed in our last class. Yes, moving to the next one, that is the characteristics of ionic compounds. Looking at the first point, that is the physical state. The physical state of ionic compounds generally exist in crystalline solids. They are generally crystalline solids. Just now I showed you the lattice, known as crystal lattice. Ionic compounds do not exist as single molecules like other gaseous molecules. Yes, they exist in combined state. Like these, they do not exist in single state, they exist in combined state. Okay, next point, melting points and boiling points. See, we said they are present as solids, crystalline solids. And how this crystal lattice is, just now we have seen, it is being held by the ions. The ions come together here. So there is strong electrostatic force of attraction between the positively charged and negatively charged ions to form this crystal lattice. So since ionic compounds, there is strong inter-ionic forces of attraction between them, right? Therefore, to break that force of attraction, we need to put more amount of energy. Therefore, we say they have generally high melting and boiling points. So because of many simultaneous attractions between cations and anions, ionic crystal lattices are very strong. Yes, so the process of melting an ionic compound requires what? It requires addition of large amount of energy in order to break all the ionic bonds in the crystal. For example, if you see, sodium chloride has melting temperature of about 800 degrees Celsius. That means when you apply that much of energy, it gets converted into liquid. Yes, so the molecular compound, if you take like water, it melts at 0 degrees Celsius. Just see, sodium chloride, it is 800 degrees Celsius. Molecular compound, say water, it is just 0 degrees Celsius. Okay, one more point comes here. The other point which comes into consideration is, it is called shattering. Yes, see, ionic compounds, we know that ionic compounds are hard. Yes, they are very hard. Yes, but they are brittle. Though ionic compounds are hard, they are very brittle. What does that mean? When you hammer them, when you apply pressure, they break down into pieces. Yes, it takes large amount of mechanical energy, such as something like, for example, you are taking a hammer and striking a crystal. Just imagine that. To force one layer of ions to shift to relative shift relative to its neighbor. So however, when that happens, it brings ions of same charge next to each other. It brings ions of same charge next to each other. Okay, so the repulsive forces between like charged ions causes the crystal to shatter. So when you hammer the crystal lattice, just now I've showed you how is the crystal lattice: positive ion, negative ion, positive ion, negative ion. So when you hammer it, suppose you are hammering it, what will happen is the when you hammer, there will be disturbance in the crystal lattice, yes, arrangement. So what happens, the similar charge ions may come near each other in the as a neighbors, they may come, yes, and these will be other charged ions like this. So similar charge ions may come nearer to each other, due to which there will be repulsion between the like charges. There will be repulsion between the like charges. So when there comes repulsion, what will happen? So when there is repulsion, they will try to move away from each other as far as possible. Therefore, it makes the crystal to shatter. It makes the crystal to shatter. Is that clear? So when ionic crystal breaks, when the ionic crystal breaks, it tends to do so long along smooth planes because of the regular arrangement of the ions. They will not blister out. Yes, they will move in a very proper manner. They'll move in a very proper manner. So this is one of the physical property of ionic crystals, I can say. Okay. The next one is solubility. They are soluble in polar solvents. See, for solubility, we have one important rule. Like dissolves like. Yes, if it is a polar compound, it will dissolve in polar solvent. And if it is a non-polar compound, it will dissolve in non-polar solvent. Water is our polar solvent. Okay. So what are these ionic compounds? They are polar compounds because they have ions, positive and negatively charged ions. So they are polar compounds. So they will dissolve in polar solvents. But they do not dissolve in organic solvents because organic solvents are non-polar. Like benzene, CCl for carbon tetrachloride. They will not dissolve in non-polar solvents. Is that clear? So solubility, they will dissolve, ionic compounds dissolve in polar solvents, but they do not dissolve in non-polar solvents. Okay. Next, electrical conductivity. In solid state, they are poor conductors of electricity, but in molten state or when dissolved in water, they do conduct electricity. I can show you this here. You can see here. Yes. Okay. So another characteristic property of ionic compounds is that, what is the property? It is electrical conductivity. Okay, it is electrical conductivity. So the figure, what you are seeing here, it shows 3 experiments in which 2 electrodes, these are the electrodes, yes, 2 electrodes that are connected to a light bulb through a battery. Yes, they are placed in the beakers containing 3 different substances. So we have taken 3 different substances. Okay. In the first beaker, distilled water is there. Distilled water does not conduct electricity because what is water? Water is molecular compound. Distilled water does not conduct electricity because water is molecular compound. In the second beaker, we have taken solid NaCl, sodium chloride. Now you may say sodium chloride is an ionic compound. Yes, sodium chloride is an ionic compound despite being ionic and thus composed of charges, positive and negative charges. The solid crystal lattice does not allow ions to move between the electrodes. So if you take here solid NaCl, this is all salt NaCl, it will not conduct electricity because it is there are ions, there are charged species, no doubt there are charged species, but these charged species, they are held intact in crystal lattice. They are held intact in crystal lattice. They are held strongly. They are not free. Only if they are free, then there will be movement of ions, and movement of ions causes a flow of charges and the bulb will glow. Yes or no? So because the ions are held very tightly in the crystal lattice, they will not move. Yes, the solid crystal lattice, it will not allow the ions to move between the electrodes. So mobile charged particles. So what is required for conduction of electricity? Mobile charged particles. Yes, mobile charged particles means what? The moving charged particles are required. The moving charged particles are required for the circuit to be complete, and then the bulb will glow. You can see here, in this case, the bulb is not glowing because distilled water is a molecular compound. In this case, though I have taken ionic compound, the bulb is not glowing because the positive and negative ions are present, but they are not free. They are held in a crystal lattice. Therefore, they will not move along between the electrodes. Yes. Now, if you consider, if you take this NaCl in a distilled water, what will happen? NaCl will dissociate. How it will dissociate? It will dissociate means what? It will break down as Na plus Cl minus. Not only in distilled water, even if you would have taken NaCl and heated it a bit, it would have come into molten state also. Yes, this is in dissolved state, or in molten state also, there would be free Na plus and Cl minus ions. Yes, there would be free Na plus and Cl minus. So in the third beaker, what I have done? The NaCl has been dissolved into distilled water. Yes, now the crystal lattice has broken apart and individual positive and negative ions can move. So where cation will move? Cation will move to one electrode, anion will move to other electrode. Cation will move to cathode, which is negatively charged. Anion will move to anode, which is positively charged. So allowing the electricity to flow. So melting of an ionic compound, or see, you can take it in molten state or in dissolved state. Melting of an ionic compound frees the ions to conduct a current. Not only dissolving in water, even if you melt the ionic compound also, it will free the ions to conduct the electric current. So ionic compounds conduct an electric current when melted or dissolved in water. So the dissolution of ionic compounds in water is shown here. Understood? Then only the bulb will glow. So in this case, in the first case, there is distilled water, molecular compound will not conduct. Though here the ionic compound is there, it will also not conduct. Why? Because the ions are not free. Only if they are free, then only they will flow between the electrodes and bulb will glow. But in this case, if you melt the ionic compound or if you dissolve the ionic compound in water, ions get free and these ions will move to each electrodes, and therefore there will be flow of current, flow of charges, and that makes the bulb to glow. Yes, you can see here. Ions are there. This is negative electrode. This is positive electrode, cathode. Positive ions are moving towards cathode. Negative ions are moving towards anode. Yes. So what are the key points what we discussed? The key points what we discussed was ionic compounds, they have high melting and boiling points. They are solids, crystalline solids, solubility, they are soluble in water, polar solvents. They have shattering property. They have electrical conductivity. They are poor conductors in solid state, but in molten state or when dissolved in water, they conduct electricity. Why? Because ionic compounds dissociate into ions. Yes, they dissociate into ions when melted or when dissolved in water. Yes. Next property is that ionic reactions. Ionic compounds produce ions in the solutions. You take any solution and put an ionic compound, it will produce ions, or you can say it dissociates into ions, which gives very fast reactions with oppositely charged ions. Yes, ionic reactions are very fast. So you can see here Na plus Cl minus. This is an ionic compound. When you put it in a solution, AgNO3 is there. Oppositely charged ions take up. So Cl minus come to Ag. Na plus goes to NO3 minus. So you'll get AgCl. This arrow mark indicates a precipitate and NaNO3 in solution. Yes. So these are called ionic reactions. An ionic compound can be identified by its chemical formula. How? There will be a metal, there will be a non-metal, or there will be a metal and there will be polyatomic ions. So this is polyatomic ions. So you can identify an ionic compound by its chemical formula only. Immediately by looking at the chemical formula, you can identify the ions, the ionic compound. Yes, and this was what experiment I had told you, right? Okay. Moving to the next one. So before going to the next type of bond, this is what we need to understand, right? Lewis dot symbol or Lewis structures. So what does Lewis dot symbol tell us, or Lewis structure tells us? Lewis structure tells us basically about the valence electrons, the presence of valence electrons. So what are these valence electrons is known to us. Yes, Lewis dot structure, it tells us about, it is used Lewis symbols, Lewis dot structures you say, Lewis dot symbols you say, it uses dots to visually represent the valence electrons of an atom. Okay, so in the Lewis symbol for an atom, what we do is the chemical symbol of the element as found in the periodic table is written. So we know every chemical symbol of the element, and the valence electrons are represented as dots surrounding it. Only the electrons in the valence level are shown using this notation. For example, they have given carbon. Okay, so how we can write for carbon? For example, carbon, its atomic number is 6. So its electronic configuration 1s2, 2s2, 2p2, right? 2, 4, 6. So outermost shell is having how many electrons? 4 electrons. So what I do is I will write the symbol of the element, and these 4 electrons are indicated as 4 dots. So this symbol is called what? It is called Lewis symbol. It is called Lewis symbol. This is how we write the Lewis symbol. So for elements, it is symbol. If you take it for compounds, for a molecule, it will be a structure. Yes, it will be a structure. So this is how we write the Lewis symbols. Yes, the Lewis symbols, they ignore the inner shell electrons. They will not consider inner shell electrons. So let us take few more examples. Like here you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, so lithium, outer shell has, so I'll write it like this, 2, 1, 2, 2, 2, 3, correct? 2, 4, 2, 5, 2, 6, 7. So this is the outermost shell. So they are having respective electrons, even hydrogen, 1. Yes or no? Okay. So how do I represent lithium? Only outermost electrons, only valence electrons are to be represented. So we need to represent only valence electrons. So Lewis, he used only valence electron representation, and he called it as Lewis dot structure. So lithium, 1 dot. Yes, you write that dot anywhere. Beryllium, 2 dots. Yes, first you have to write each dot at 4 corners, then you can do the pairing. Boron, 1, 2, 3. Carbon, 1, 2, 3, 4. Nitrogen, see, 1, 2, 3, 4, and then 5. Correct? Oxygen, 1, 2, 3, 4, 5, 6. Yes or no? Fluorine, 1, 2, 3, 4, 5, 6, 7. Is that right? Neon, 1, 2, 3, 4, 5, 6, 7, 8. So this is how we write the Lewis symbols. This is how we write the Lewis symbols. Yes. So Lewis, what is the significance of Lewis symbols? So carbon is given here. You can see here. Hydrogen, 1. Helium, 2. Lithium, beryllium, boron, carbon, nitrogen. Similarly, sodium, outermost shell, 1 electron. Magnesium, aluminium, silicon. Whatever elements come in a group, they will have same Lewis symbol. Only the as chemical element symbol changes. So dots will be same. See, carbon, silicon, 4 dots. Boron, aluminium, 3 dots. Because their valence electrons will be same. Nitrogen, 5. Phosphorus, 5. Oxygen, 6. Sulfur, 6. Fluorine, 7. Chlorine, also 7. All noble gases 8 except helium. Helium will have 2. Yes. So this is how we write the Lewis dot diagrams for first 20 elements. Yes. For all the elements also you can write. If you know to which period and you know how to calculate to which period, to which group, and to which block it belongs. So once you know that, you can write the Lewis symbol. Simple example. If I say yes, 21, an element with atomic number 21. 21 is there. So you can 21, or you can say 31 is there. An element with atomic number 31 is there. What write the Lewis dot structure for that element with atomic number 31. So when I say 31, you will write 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So it became 20, 3d10. Then after 3d comes 4p1, correct? So outermost shell has 4s2 and 4p1. How many electrons? 3. So outermost shell is having 3 electrons. It below last electron is entering to p subshell. So p block, it is having 3 electrons and it is in p. Therefore 10 plus 3 is how much? It is 13. So it belongs to 13th group. So when we say it belongs to 13th group, it is boron family. Therefore, how will we write this dot structure? 1, 2, 3. 3 electrons in the outermost shell. Is that right? Yes. So this is how we write the Lewis dot structure for the atoms of various elements. What is the aim of Lewis structures? The aim of Lewis structures is to provide a simple way for the chemists to view the molecules that allows accurate predictions about the actual molecules and structure and properties to be made. So looking at the Lewis symbol, see, looking at this symbol, you can say with how many bonds it can form, with how many atoms it can combine to form a bond. Understanding? So example I'll give you, aluminium has got 3 dots. Aluminium forms AlCl3 compound, see, with 3 chlorine atoms. Silicon, SiCl4. Phosphorus, PCl5, and even we have PCl3. Yes, so looking at the Lewis symbols, we can actually predict the chemical, some of the chemical properties of the compounds. We can actually predict some of the chemical properties of the compounds. Therefore, Lewis symbol, which represents, what it represents, the number of valence electrons in the outermost shell. It represents the number of valence electrons in the outermost shell. That helps us. What it helps us? It helps us to identify what are the different chemical reactions which come under this particular element. So if you have Lewis structures is for what? Lewis structures are written for molecules. So drawing Lewis structures. So count the number of valence electrons. For a molecule, add up the valence electrons of the atoms. Draw a skeleton structure joining atoms by single bonds. The central atom is usually written first in the formula. Determine the number of valence electrons still available. Subtract 2 electrons for each single bond written. Determine the number of valence electrons required to fill an octet for each atom, except hydrogen. If electron available is equal to electron required, distribute the available electrons as unshared pairs. If the number of electrons available is less than number of electrons required by 2 electrons, change a single bond into a double bond. If you are 4 electrons short, convert a single bond into a triple bond. Carbon, nitrogen, oxygen, sulfur can form multiple bonds. Hydrogen and halogens never form double bonds. So with this proper explanation, I can show you some of the examples. So far you have written the Lewis symbols for atoms. What if I wanted to write for molecules? Like for example, I want Lewis symbol for F2 molecule. So what I can do? First, what I need to do is, please do remember this format. T, P, S, U. Yes. So T stands for what? T stands for total number of electrons. Now, what does this total number of electrons means? We know that whenever atoms are combining, why do they combine? To have 8 electrons in their outermost shell. Understanding? So to have 8 electrons in their outermost shell, they will combine. So I need to see all atoms with 8 electrons, except for hydrogen, because hydrogen tries to have how many electrons? It tries to have 4 electrons in its outermost shell. Sorry, 2 electrons in its outermost shell, correct? Okay. Then V, total number of valence electrons. Total, okay, valence electrons, total valence electrons. S is formula, I'll tell you, T minus V, and U is V minus S. So if you know T and V, you can calculate S and U. What does S stands for? S stands for shared electrons. Shared electrons means what? It stands for the electrons which are participating in bond formation. and U stands for unshared electrons. U stands for unshared electrons. Okay, so let us see now. F2. F2, fluorine atom tries to combine. So when it is trying to combine, it will have 8 electrons, right? So 8 into 2 is how much? 16. Valence electrons. What is the number of valence electrons on fluorine? It is 5. There are 2 fluorine atoms, 5 into 2. It is 10. Now, shared electrons, T minus V. 16 minus 10 is how much? 6. Unshared electron. I'm sorry. Fluorine has got 7. I'm sorry. There are, that's what somewhere I went wrong. Fluorine has got 7 valence electrons. So 7 into 2 is how much? 14. And what is 16 minus 14? It is 2. These are electrons, okay, not pairs. Unshared electrons, V minus S. 14 minus 2 is how much? It is 12. So these are electrons. So let us write the structure. I'll write 2 fluorine atoms. How many shared? Shared electrons means which are involved in bonding. How many electrons are there? 2. I will write 2 electrons here. Yes? Okay. Or I will represent it as a bond. I will represent it as a bond. Unshared. Now I have to fill the unshared electrons. There are 12 unshared electrons. I have to fill the unshared electrons such that each fluorine atom will have octet. Now this 2 electrons are for this fluorine. These 2 electrons are for this fluorine also. They are shared between the 2. So with the 2, how many more electrons for this fluorine? 6 more. 1, 2, 3, 4, 5, 6. Correct. And for this 6 more. 1, 2, 3, 4, 5, 6. Observe. With such configuration, has this fluorine atom completed the octet? Yes. 2, 4, 6, 8. Yes. What about this fluorine? Observe. Has it completed the octet? Has it completed the octet? Can you see here? 2, 4, 6, and 8. Yes. So this is how we write the Lewis structure. Or you can show a bond for shared electrons. And these are unshared electrons. Unshared electrons means what? See, please do remember, when we speak about valence electrons, there will be 2 types. The electrons which are involved in bonding and which are not involved in bonding. The electrons which are involved in bonding are called bonded electrons, or you call them as shared electron pairs. Shared electrons you say, shared electron pairs you say. The electrons which are not involved in bonding are called non-bonded electrons, or you can call them as unshared electrons or electron pairs. When I say unshared electrons, it will be 6 for fluorine, each fluorine, and 6 for this fluorine. When I say unshared electron pairs, it will be 3 pairs for each fluorine. Yes or no? Or they are also called lone pairs. They are also called lone pairs. Yes, understanding. So this is how we write the Lewis structure for a molecule. Yes, to understand this Lewis structure, first we need to understand one more concept. That is covalent bond. Lewis-Langmuir concept. So what do we mean by a covalent bond? Okay. Okay. So we have discussed about ionic bond. We have discussed about what is ionic bond. Now what we are going to discuss is what is a covalent bond. So what do we mean by a covalent bond? What is ionic bond? When the bond is formed by complete transfer of electrons. Okay. When the bond is formed by complete transfer of electrons, we call it as an ionic bond. One atom is losing the electron, another atom is gaining the electron. This covalent bond, it was for the first time proposed by Lewis in the year 1916. See, sometimes what happens when I have taken 2 same atoms. So in that case, I cannot expect one atom to lose electron and another atom to gain electron. Are you all understanding what I'm trying to say? Let me take this example. Suppose I have same example I'll consider 2 fluorine atoms, and I know that each fluorine atom, the configuration is 2, 7. This is also 2, 7. Okay, let us say this fluorine will lose electron, which is impossible because fluorine atomic size is very small. It cannot lose electron. Let me say I'm going to apply very high ionization energy and it is going to lose electron. Okay, fine. If it loses electron, that electron is being taken up by this fluorine and it will have 8 electrons in its outermost shell. But what about this? By losing the electron, is it having 8 electrons in its outermost shell? No. Even in ionic bond, or you consider any bond, the atoms tend to attain stability by losing or gaining electrons. Yes or no? This is 281, this is 27. So sodium will lose 1 electron. Why it will lose 1 electron? Because it will have 8 electrons in its outermost shell. It becomes octet by losing 1 electron, Na plus. Fluorine will gain that 1 electron and that will also become octet configuration in its outermost shell. It becomes 28. So all the atoms tend to have octet configuration. Understanding? In ionic bond, so far we have seen. But what here? What about this case? And the ionic bond is formed between metals and non-metals, we said. Here, the two atoms are same. When the two atoms are same, what do I expect? What will happen? What actually happens? Can I expect one to lose electron and another one to gain? Can I expect a transfer of electrons? That is not possible because one atom becomes stable, but another remains unstable. Yes, and stability is achieved when both the atoms attain octet configuration. In such cases, what will happen is this is having 2,7 configuration. This is also having 2,7 configuration. Let us write Lewis dot structure for dot symbol for each of them. So fluorine has got 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. This fluorine also has got 7 valence electrons. Correct? So see what happens is instead of transferring electrons, each fluorine atom will share electrons. Now this fluorine atom will contribute 1 electron. This fluorine atom will also contribute 1 electron. Such contribution we say mutual sharing. What we say? Mutual sharing. So both fluorine atoms are sharing 1 electron each. It's not that this is sharing 2, this is not sharing anyone. No. Both there is mutual sharing. Mutual sharing means what? Mutual sharing means equal sharing. If this is sharing 1 electron, this is also sharing 1 electron. So when they share, when there is mutual sharing, what will happen? There will be an electron pair which is shared, and that is called shared electron pair. That shared electron pair will be for both the fluorine atoms. It will be for both the fluorine atoms. So it will be for this fluorine atom as well as it will be for this fluorine atom. Understanding? So the electron pair which is being shared by both the fluorine atoms, it will be for both the fluorine atoms. And what remained? Here 3 pairs of electrons are remaining. Here also 3 pairs of electrons are remaining. Now see, after sharing 1 electron each, have they completed their octet? 2, 4, 6, 8. 2, 4, 6, 8. Yes, both of them are having octet configuration. That is 8 electrons in the outermost shells and both have become stable. So unlike a transfer, there is no transfer. Unlike transfer, there is mutual sharing of electrons. Yes, when there is mutual sharing of electrons, such bond is called what? It is called covalent bond. It is called covalent bond. The bond formed by mutual sharing of electrons between the two combining atoms. And those electrons which are involved in sharing, can you see these electrons? That those electrons are called shared electrons or shared electron pairs. If I say shared electrons, there are 2 electrons. If I say shared electron pairs, there is only 1 pair, right? So they are called shared electrons or shared electron pairs. And out of 7, there are 3 pairs of electrons which are not shared. They are not involved in sharing, yes or no? They are called unshared electrons or unshared electron pairs. If I say unshared electrons, there are 6 electrons on each fluorine. Unshared electron pairs, 3 pairs of electrons, which are also called as what? Lone pairs. When I say pairs, we'll consider 2 electrons each. So how many lone pairs are there in fluorine? 3 lone pairs on each fluorine atom. In fluorine molecule, how many lone pairs? 3 lone pairs on one fluorine atom, 3 lone pairs on other. So there are 6 lone pairs. Please try to understand. These are shared pairs or bond pairs. So in fluorine atom, there is 1 bond pair and there are 6 lone pairs. Understanding? Yes. So this is about fluorine. What if I want to do hydrogen molecule? Yes, I know that hydrogen, it is having only one electron. This hydrogen also has one electron. Now, can it complete its octet? No. Here, the capacity of hydrogen is 1s orbital. It can have maximum 2 electrons. Therefore, this hydrogen will share one electron. This hydrogen will share one electron. There is mutual sharing between the two hydrogen atoms, such that this electron pair is for this hydrogen and this electron pair is also for this hydrogen. So though it has not completed octet, there is no octet possible for hydrogen. Has it completed its duplet? Yes, therefore it becomes stable molecule. So in hydrogen, there is only one bond pair. Yes or no? Are there any lone pairs? No. So hydrogen has one bond pair. Is that right? Okay. Now consider chlorine molecule. Cl, Cl. Chlorine atomic number is 17. So it is 287. Outermost shell has 7 electrons, same as fluorine. So I will write 7 electrons here, 7 electrons here. Can it involve in share transfer? No, they will be involved in sharing. So this will contribute, this will also contribute. So I'll have Cl. There will be how many bond pairs? There will be one bond pair, and rest all are what? Rest all are unshared pairs, which are called as lone pairs. Which are called as lone pairs. Is that right? So here, this chlorine is having 8 electrons in its outermost shell. And here also there are 8 electrons in its outermost shell. Yes or no? 8 electrons, 8 electrons. Completed octet. So chlorine molecule, it is having one bond pair. And how many lone pairs? 1, 2, 3, 1, 2, 3. 6 lone pairs in chlorine molecule. Okay. Yes, understood till here. So this is about covalent bond, the bond formed by mutual sharing of the electrons. Let me consider one more example. Oxygen molecule. For oxygen molecule, I need 2 oxygen atoms and oxygen atomic number is 8. So it is 2, 6. That means outermost shell valence electrons are 6. So I will write 1, 2, 3, 4, 5, 6. And similar here. Correct? 6. Now see this, can it form a transfer of electrons and ionic bond? No, because both atoms are same. Electronegativity difference is 0. Correct? Therefore, this will share one electron, this will share one electron. Now just observe, by sharing one electron each, oxygen, what remains, I'll write it here. And here there is sharing of one electron pair and oxygen, 2, 2 and 1. Has it completed octet by sharing one electron? 1, 2, 3, 4, 5, 6, 7. No. 1, 2, 3, 4, 5, 6, 7. No. Therefore, since by sharing one electron, unlike hydrogen, chlorine, fluorine, since by sharing one electron, these have completed their duplet and octet. But here, oxygen by sharing one electron, mutual sharing of one electron, it has not completed its octet. So what oxygen will do? It will share its 2 electrons. So this oxygen is sharing 2 electrons. This oxygen also will share 2 electrons. Getting my point? So it will share 2 electrons instead of 1. So when it shares 2 electrons, let us see. So it is sharing 2 electrons. Okay, fine. Now observe. Correct? By sharing 2 electrons each, has both oxygen atoms completed their octet? See, 2, 4, 6, 8. Yes, 2, 4, 6, 8. So oxygen, unlike chlorine, fluorine, instead of sharing one electron each, they have shared 2 electrons each and they have completed the octet. Yes. So in oxygen molecule, and they have become stable, right? How many bond pairs are there? There are 1, 2 bond pairs. So there are 2 bond pairs. And how many lone pairs? 1, 2, 1, 2. There are 4 lone pairs. Total oxygen atom. Total oxygen molecule. Understanding? Therefore, this molecule, I can represent it like this also. Oxygen, 2 bond pairs and oxygen. Here there are 2 lone pairs and here also there are 2 lone pairs. Is that clear? Chlorine, I will represent it like this. I will represent it like this. Okay, understanding? So there will be 2 bond pairs between oxygen atom. Consider N2 molecule. Nitrogen, nitrogen. Nitrogen atomic number is 7. So it is 2, 5. So there are 5 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So nitrogen will share 1 electron each. By sharing 1 electron each, let us see. There will be 1 shared electron pair. Then this nitrogen will have 2 and remaining 2 here. 2 electrons and remaining 2. Has it completed its octet? 2, 3, 4, 5, 6. No. So what nitrogen will do? Instead of one sharing one electron each, it will share 2 electrons each. Correct? Okay, let us see now. So let me say these 2 electrons are shared. So where they will come? They will come here under shared pairs. Have they completed their octet? 1, 2, 3, 4, 5, 6, 7 and 7. No. Therefore, what nitrogen does, instead of sharing 1 or 2, it will share 3 electrons each. It will share 3 electrons each. So let us see. So it is going to share this electrons also. Correct? Okay. So it will share 3 electrons each. Now you observe. By sharing 3 electrons each, has the nitrogen completed the octet? 2, 4, 6, 8. 2, 4, 6, 8. Yes. So nitrogen molecule, it has got how many bond pairs? 1, 2, 3. It has got 3 bond pairs and 2 lone pairs, 1 on each nitrogen. And therefore, I can represent nitrogen molecule writing like this. Correct? So 1 bond means what? 1 bond pair means 2 electrons are there. 2 bonds means what? There are 2 pairs of electrons. 3 bond pairs means what? 3 pairs of electrons. All these are examples for covalent bonds. Yes. A covalent bond is for what? Is what? A covalent bond. A bond formed by mutual sharing of electrons. Bond formed by mutual sharing of electrons between the 2 combining atoms, equal sharing, is called a covalent bond. Now, if you consider these 3 examples, H2, F2 and Cl2, here a covalent bond is formed by mutual sharing of 1 electron pair, correct? Can I say 1 electron pair between the 2 combining atoms, or 1 electron each you can say. So a covalent bond formed by mutual sharing of 1 electron pair is called single covalent bond. What it is called? Single covalent bond. So mutual sharing of 1 electron pair between the 2 atoms, between the 2 combining atoms. It is called single covalent bond. In case of O2, a covalent bond is formed by mutual sharing of 2 electron pairs. A covalent bond formed by mutual sharing of 2 electron pairs is called double covalent bond. It is called double covalent bond. And a covalent bond formed by mutual sharing of 3 electron pairs. Yes, it is called what? Covalent bond formed by mutual sharing of 3 electron pairs. It is called triple covalent bond. So in covalent bond, we have 3 types: single covalent bond, double covalent bond, and triple covalent bond. So a covalent bond formed by mutual sharing of single electron pair, 1 electron pair, is called single covalent bond, and it is represented by a single dash. Bond. Dash represents what? It is represented as bond. What is a double covalent bond? A bond formed by mutual sharing of 2 electron pairs. So there are 2 bond pairs, 2 electron pairs. It is called a double covalent bond. And the bond formed by mutual sharing of 3 electron pairs is called a triple covalent bond. It is called a triple covalent bond. Even apart from this, you have a few more examples also. Like for example, if I say HCl molecule, I have one more, say NH3 molecule. Yes, so here we know hydrogen, 1 lone, 1 valence electron, chlorine 7. So it cannot lose and gain one electron. Therefore, what it will do? It will share electrons. So it will share like this. Now, by sharing electron, has hydrogen completed its duplet? 2 electrons? Yes. Then has chlorine completed its octet? Yes. Chlorine also has completed its octet. Therefore, this is what type of a bond? This is single covalent bond. Understanding? Similarly, NH3, nitrogen, I know 1, 2, 3, 4, 5, and hydrogen 1 dot. There are such 3 hydrogens. I will write 3 dots. Yes. So it will share 1 electron of nitrogen is shared with 1 electron of 1 hydrogen. Another electron of nitrogen is shared with 1 electron of another hydrogen. Third electron of nitrogen is shared with another electron of other hydrogen. So by doing so, has hydrogens completed their duplet? Yes. And has nitrogen completed its octet? Check. 2, 4, 6, 8. Yes. Yes. Sometimes you will get molecules, polyatomic molecules. In that case, how to write the Lewis structure? These are all Lewis structures, right? The shared pairs are indicated by bonds. That's it. And these are unshared pairs which are indicated as dots only. So thus such structures are called Lewis structures. Yes. Lewis symbols are for atoms. Lewis structures are for molecules. So how to write Lewis structures? Yes. How to write the Lewis structures? Okay. So now let us consider. I'll take simple first ammonia molecule only. Okay. So what I'll do? T, V, S, U. I had told you. Do you remember? Total number of electrons. Nitrogen will try to have 8 electrons. Octet plus. Does hydrogen will have 8? It will have 2. Into how many hydrogens? 3. Yes. So 2 3s are 6. 8 plus 6. 14. Valence electrons on nitrogen? 5. Hydrogen 1 into how many hydrogens? 3. So how many? 8. 14 minus 8. How much? 6 electrons. Not pairs. Okay, 6 electrons. Then 8 minus 6. 2 electrons. Unshared. So U stands for what? U stands for unshared. When you are writing the Lewis structure, see that electropositive element comes in the center. But if the molecule contains hydrogen, then hydrogen is always written at the terminal. Do remember. So what I will do? I will write nitrogen. Then hydrogens are written at the terminals. 3 hydrogens surrounding nitrogen. How many shared electrons are there? 6. So 1, 2, 3, 4, 5, 6. If there would be 8, what I would do after writing shared electrons for each of the bonds, I would have started with double bonds. Remember it. Okay. How many unshared electrons are there? 2. Now those unshared electrons should be written such that they will complete their octet or duplet. By this shared electron, has hydrogen completed its duplet? Yes. This hydrogen also completed its duplet. This hydrogen also completed its duplet. But has nitrogen completed its octet? 2, 4, 6. Therefore, 2 unshared electrons come on what? It comes on nitrogen. Understanding? This is how we write the structure for molecule. Take one more example. CO2. T, V, S, U. Total number of electrons. Carbon 8 plus oxygen also 8 into 2. 8 to the 16 and 16 plus 2. 24. Correct? Valence electrons on carbon 4. Valence electrons on oxygen, carbon 2 and 4 we write. On oxygen, it is 2 and 6. So valence electrons on oxygen are 6. 6 into 2 is 12. 12 plus 4, 16. 24 minus 16 comes out what? 8. Correct? 16 minus 8 is what? 8. So 8 shared electrons are there, 8 unshared electrons are there. Correct? When you're writing, electropositive should come at the center. So carbon is less electronegative, you can say. And oxygens, 2 oxygens are there. I'll write 2 oxygens like this. How many shared electrons? 8. 1, 2, 3, 4. So still 4. 1, 2, 3, 4. Because there are no other atoms to form bonds. correct? So you can show them as bonds also, correct? Unshared are 8. Okay, let us see. Now each atom should have 8 electrons, correct? Let us start with carbon. Carbon is having how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. So carbon has completed its octet. Yes or no? Carbon has completed its octet. What about oxygen? How many electrons? 1, 2, 3, 4. 1, 2, 3, 4. So how many more for octet? 4 more on this oxygen and 4 more on this oxygen. Yes. So this now let us check. So 8 electrons and 8 electrons are satisfied here. Have this oxygen completed the octet? 2, 4, 6, 8. This oxygen 2, 4, 6, 8. So this is the structure of carbon dioxide molecule. I can write it like this also. So each oxygen atom is held with a double covalent bond with oxygen with carbon atoms. Is that right? So this is how we write the Lewis structures. We write the Lewis structures. Okay. Okay. A covalent bond, equal sharing of electrons from both the participating atoms. The pair of electrons participating in this type of bonding is called shared pair or bonding pair or bond pairs. The covalent bonds are also termed as molecular bonds. Sharing of bonding pairs will ensure that atoms achieve stability in their outermost shell, which is similar to atoms of noble gases. That means they will have 8 electrons in the outermost shell. If the combining atoms are same, the covalent molecule is called homoatomic. That means H2. Combining atoms are H2, HH, two hydrogen atoms. Then it is homoatomic molecule. Same atoms, having same atoms. If the combining atoms are different, it is heteroatomic. What are the examples for heteroatomic we have seen so far? It is HCl, heteroatomic covalent molecule. Then it is NH3 we have seen, heteroatomic covalent molecule. Then it is carbon dioxide, heteroatomic covalent molecule. These are all examples for heteroatomic covalent molecules. Yes? Okay. So here, see here, covalent bond, hydrogen atom, 1 electron, hydrogen atom, 1 electron, both are involved in sharing, mutual sharing. So these 2 electrons are for both hydrogen atoms in the hydrogen molecule. Hydrogen molecule, so it is shown by single bond. Oxygen molecule, it is also shown here. Water molecule, see, oxygen is there at the center, 6 lone pairs, 1 electron, 6 valence electrons. 1 electron is being with hydrogen of 1 atom, another electron with hydrogen of 1 atom. So duplet for hydrogen, duplet for oxygen, octet for duplet for hydrogen, octet for oxygen. 2, 4, 6, 8, and this is oxygen water molecule. Yes. So Lewis representation of simple molecules. Just now I told you. Calculate total number of valence electrons of combining atom. Each anion means addition of 1 electron and each cation means a removal of 1 electron. So anion, we have not seen examples for anions and cations so far, right? So anion means addition of 1 electron, cation means removal of 1 electron. Okay. Then after placing shared pairs of electrons for a single bond, the remaining electrons may account for either multiple bonds or lone pairs. It is to be noted that octet of each atom should be completed. Octet of each atom should be completed. So here, carbon monoxide, it is written like this. There is triple bond, carbon here, carbon, oxygen here. Carbon dioxide, just now we have seen. O2 molecule also we have seen. There is double. They have made a slight mistake here. This will not come. Okay, so double bond, these are for oxygen atoms, correct? So we get this O3 molecule. It is written like this. I can show you all if you want. We'll take O3 molecule and then we will take up the ions, molecular ions. Okay, O3 molecule. So T, V, S, U. We have to calculate. Oxygen 8, 8 into 3. 24. Valence electrons on each oxygen, 6 into 3, 18. So 24 minus 18 is how much? 8. No. Sorry. So 24 minus 18 is 6. Correct. Then 18 minus 6 is how much? It is 12. So let us, so these are electrons, these are electrons. Let us write and see. Okay. So when you're writing oxygen molecule, so oxygen, 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 3 atoms are there, 6 electrons which are shared. So 1, 2, I'll show a bond directly, or you can show it like this, 3, 4. So how many became? 4 electrons became, 1 more. So I can write a double bond here, or I can write a double bond here, correct? So totally 6, 2, 4, 6. Now how many unshared? 12 are there. You should write unshared electrons such that each oxygen will have its octet. This oxygen is having how many? 2, 4. So how many more? 2, 4. Has it completed its octet now? Check out. So by writing 2 pairs of electrons on oxygen, has this oxygen completed octet? Yes. Now this oxygen is having how many electrons? 2, 4, 6. So how many more? 1 electron more, pair more. Now just check out by writing that pair, has this oxygen completed its octet? Check out. Yes, 2, 4, 6, 8. Yes. And this oxygen, there are only 2. So I'll write 1, 2, 3, 4, 5, 6. Now check out by writing 3 electron pairs, has this oxygen completed its octet? 2, 4, 6, 8. Yes. So total unshared electrons, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Has it satisfied? Yes. So this is the Lewis structure for O3 molecule. Okay. Now what if I have ions, like for example, CO3 minus 2. What is this ion called? It is called carbonate ion, or this is a negative ion. Okay. What if I have NH4 plus? This is called ammonium ion. Excuse me. Excuse me. Okay. So let us see what changes will come. I'll tell you. Again, we are going to calculate T, V, S, and U. What does T stands for? Total number of electrons. V, valence electrons. S, shared electrons, and U, unshared. So T, V, S, U. Correct? Okay. T, total number. Carbon, 8. Oxygen also 8. If it was hydrogen, we would have written 2. So 8 3s are 24. 8 4s are 32. Total electrons are 32. Total electrons. Valence electrons. Carbon has how many valence electrons? 4. Plus oxygen 6. 6 3s are 18. Now see, minus 2 means what? It is gain of 2 electrons. Anion means gain of 2 electrons. And that will be gained in valence shell only. Therefore, I will write minus 2 means what? Gain of 2 electrons. So I will write plus 2 here. Understanding? So this negative or positive sign should come in valence, because electrons will be gained or lost in valence electrons or from valence electrons. So 18 plus 2 is 20. You understood why I wrote plus 2? Because minus 2 means gain of 2 electrons. So 2 electrons are gained by this this molecule. So plus 2. So this becomes 24. Correct? How do you calculate shared electrons? It is 32 minus 24. How much you get? 8 electrons. How do you calculate unshared electrons? V minus S. 24 minus 8. How much? 16 electrons. So let us try to write the structure. Electropositive at the center, carbon. So here 1 oxygen, here 1 oxygen, and here 1 oxygen. Correct? Now, how many shared electrons? 8. 1, 2. 1, 2. 1, 2. So how many shared electrons? 2, 4, 6. I want 8, one more. So that one more is written as a multiple bond. I can write it here, I can write it here, or I can write it here. Suppose I write it here. So did 8 electrons finished? Yes, 8 electrons got over. Now unshared electrons should be written such that each atom will satisfy its octet configuration. Oxygen is having how many? 4. How many more are required? 2 more. Carbon is having how many? 1, 2, 3, 4, 5, 6, 7, 8. So it is not required. This oxygen 2. So how many more? 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen is having 2, 3, 4, 5, 6, 7, 8. After writing, we have to verify. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 electrons are there. Yes. Now you verify the octet for oxygen. Has it completed the octet? Yes. Octet for this oxygen. Has it completed the octet? Yes. 2 and these 6, 8. Octet for this oxygen. Has it completed the octet? Yes. Now, duplet octet for carbon. Octet for carbon. So let us verify. Has it completed the octet? Yes. Has it completed the octet? Yes. 2, 4, 6, 8. So all the atoms have completed the octet. When I have such ion, so what I will do is I will write a block like this and I will write -2 here. I will write -2 here. Understanding? So this is how I represent Lewis structure for polyatomic. This is anion. What if I have cation? Same thing. Nitrogen 8 electrons plus hydrogen will have hydrogen will have 2 electrons. 2 into 4. Sorry. Hydrogen will have how many electrons? It is 1. Okay, sorry, it is 2. It will complete duplet. Right? So 2 into 4, 2 4s are 8, 8 plus 8 is 16. Valence electrons on nitrogen, 5. On hydrogen, this is 5. On hydrogen, there is only 1 valence electron into 4. Now, plus 1 means what? Loss of 1 electron. So, -1 I'll write here. So, 5 plus 4 minus 1. This is 9 minus 1 is 8. 16 minus 8 is how much? 8. 8 minus 8 is how much? 0. So let us write the structure. When it is hydrogen, all the hydrogens are written at the terminals. So I will write hydrogens here. How many shared electrons? 8. So 1, 2, 3, 4, 5, 6, 7, 8. So here there is 1 bond, 1 bond, 1 bond, 1 bond. How many unshared? 0. Has hydrogen completed its duplet? Yes. All the 4 hydrogens, have they completed their duplet? Yes, all the 4 hydrogens have completed their duplet. Has the nitrogen completed its octet? 2, 4, 6, 8. Yes, the nitrogens has completed its octet. And here, how do I write it? I will put a box and I will write plus. So this is how I write Lewis structure for polyatomic ions. Anion, add 2 electrons in the valence shell. Cation, subtract 2 electrons, subtract the electrons from the valence shell. It is +1, -1, +2, -2 I would have done. Here -2, +2, -1, +1. That should be done in the valence shell. So this is how we write Lewis structures for molecules, molecular anions, molecular cations. So with this, we'll stop the class. In the next class, in the next video, I will discuss the next part of covalent molecules, covalent compounds. And you can see here all the H2O2, it is represented like this. You can verify it with your Lewis structures. SO3, it is written like this. HCl4, which is called perchloric acid. This is sulfur trioxide. It is written like this. Yes. So this is, you can try out H2O2, try out at home and verify whether it is correct or no. SO3, try it out home and verify whether it is correct or no. Perchloric acid, verify. For all covalent molecules, you can write the Lewis structure and verify them. Yes. Okay. So this is how we write the structures. So in the next class, I will go for properties of covalent compounds and further part of the topic. Please practice it. For now, thank you.